So my name is Nairi Pinder. I work at the Met Office and I work in the International Development team, managing our engagement with global partners who are either financing or working within the development environment to improve early warnings and early action in Asia and Africa mainly. But obviously the Met Office operates globally as well in terms of providing our weather and climate services. I am very happy to be joined by John Farragher today, who also works in our team and is an international development manager, having more recently, hello John, having more recently been working in East Africa on a project called Highway, which was FCDO funded. And he's going to be helping us on the technical side, but also managing a lot of your fantastic questions through chat, which I'm sure we'll be getting many of after our first presentations. Then we also have with us Irene Amaron, who is with the Red Cross Climate Centre and is a technical advisor for forecast-based financing. And she's going to be answering a pertinent question after we present on our imaginary country and predicted climate projections for that country. So watch this space on that one. We are also joined, and I'll introduce everybody in a bit more detail just before the questions. Our climate scientist and climate services expert for international engagement for the Met Office. And he's going to follow a weather bulletin that we're just about to show you, which will help to set the scene for future climate projections work at the Met Office, but also with our partners and how we can better use this information to help our planning across all timescales, and also including actions that we're taking now. So without further ado, I'm going to hand over to John, who's going to put on our weather presentation.
It's Christmas Eve 2054 and welcome to this global weather roundup for the big day tomorrow. Now let's start with Europe, where we find low pressure to the north of Scotland. We can expect a wild rather than white Christmas for the UK. Wet and windy in the north and west, 8 Celsius in Edinburgh, 12 in London. It's also unsettled in the Alps, but really not great ski conditions. Heavy rain on lower slopes of the Alps, snow confined to the higher resorts. Very mild westerlies extend across much of northern Europe, which means very few places will see freezing conditions during the daytime. In fact, below zero temperatures are only really likely in the far north of Norway and Finland and much further east across Russia, despite the time of year. Of course, further south across the globe, it's midsummer, and midsummer heat can be found in western parts of South Africa as well as Namibia. With heavy rain expected further east to the north of Durban, drier and sunnier conditions are expected in the west. Widely, temperatures will peak into the low to mid-30s with a high of 39 degrees in Namibia. The heatwave intensifies further south after Christmas Day, with temperatures reaching 40 Celsius in the south of South Africa by the 28th. This could have serious impacts on health, and if the heatwave becomes prolonged, could also threaten crop yields. But the hottest weather this Christmas is expected in Australia, with heavy rain expected in eastern parts of Queensland. Across much of the interior, it's the very high temperatures that are the main concern. Temperatures will widely exceed 40 degrees, and it will be unusually hot in South Australia and Victoria. The hotspots will be 48 Celsius in northern parts of South Australia. Authorities have issued health alerts for parts of Victoria, and fire warnings are in place for several other states, including Western Australia and South Australia. Extra doctors, paramedics, nurses and call centre staff will be working throughout Christmas because of the forecast conditions. Thankfully, this isn't a real forecast. But it is one possible scenario for the type of weather we could see at Christmas around the world in about 30 years' time. Now, possible and could are words that express uncertainty, but don't let that lull you into a false sense of security. There is a range of potential weather we could experience in 2054. This partly depends on natural variations in climate year to year. But beyond 2050, the amount we reduce greenhouse gases today will have an increasing effect on global warming. Greenhouse gases such as carbon dioxide have been rising in our atmosphere since the Industrial Revolution. And in that time, the world has warmed by more than 1 degree Celsius. This forecast was based on a high emissions scenario, but at this time horizon, there isn't so much difference between scenarios. The big differences occur during the second half of the century. It's a useful way to illustrate how global weather patterns may change and what they could look like if we don't curb emissions. Now, in this particular year, an El Niño happens to emerge in the computer model simulation we looked at here. Other simulations produce El Niños in different years. The dates of specific events can't be predicted this far in advance, but we can still expect El Niños to happen every few years. This climate phenomenon can lead to warmer weather across parts of South America, as well as warmer and drier weather in South Africa and parts of Australia. This is apparent in the global temperature anomaly map for Christmas Day 2054. It compares maximum temperatures on this particular day in 2054 with the 30-year global average from 1981 to 2010. Now, the red areas show that many parts of the world are warmer than the long-term average in recent decades. There are still some cold spots, and that's because it's one computer simulation of the weather on a single day, just the same as our current weather forecast you see online and in television. The main difference being the composition of the atmosphere. But as you can see, there is much more red on the map than blue. As we saw in the forecast, South Australia and Victoria were much hotter than we would expect to see today. But the most extreme warming was found in North America, Northern Europe and Northern Russia. Some places within the Arctic Circle were more than 20 degrees above the present-day average. These are cold places anyway, and it's the middle of winter, but this extreme warming can have serious consequences on snow cover, permafrost, and Arctic sea ice extent. The climate is already changing, so we already have an idea of what these types of conditions will feel like. The extraordinary Siberian heatwave during the first half of 2020, which resulted in wildfires, loss of permafrost, and an invasion of pests. The Australian wildfires of 2019 to 2020 and the Cape Town drought between 2015 and 2017. Anthropogenic climate change played a role in all of these events, along with other factors. Decision makers now face the dual challenge of reducing emissions and managing risks associated with the transition to a low-carbon economy, whilst also adapting to changes in our climate now and in the future.
Excellent. Thanks so much, John, for sorting that out. And I hope you all enjoyed our exploration into the future. It's fresh off the cutting room floor. So now I'm going to, bearing that in mind, which hopefully helped to put you into the idea of what we can expect in the future from the climate, I'm going to introduce you again now to Dr. Joseph Darren, who's the Science Manager in the International Climate Services team at the Met Office. Now, he works with organisations across the world to develop or co-develop and deliver climate services to inform climate risk management and policy decisions. He is now going to present you with a scenario of the climate for an imaginary country. And this is going to help us frame a little bit of the discussion that we have afterwards with our other experts from the World Food Programme and the World Bank and the Red Cross Climate Centre. So Joe, if you will, if you're happy to start.
Yep, thanks very much, Nairi. Just to double check, you can hear me and see the slides?
Yes, all good, thank you.
Perfect. Okay, yeah, thanks, Nairi. So I'm going to present a hypothetical example, but based on real data and examples to imagine what climate trends, projections, and impacts might be for an imaginary country to set the tone for some of the discussion that follows. So we'll focus on tropical cyclones and rainfall and thinking about past climate trends. This is a graph from 1990 to the present day, looking at the number of days that a tropical cyclone is present in a neighboring ocean to imaginary country. In the black line there, you can see the total number of tropical cyclone days per year. In the blue line, you can see the category 1 and 2, the weakest of the tropical cyclones, and category 3 to 5, the strongest cyclones, in the orange line. So what you can see from this graph is there is high year-to-year variability. But if you look at the average over each decade, you can see that in the 1990s, we have 35 days, the 2000s, 41 days, and 2010, 49 days, so a slight increasing trend. And this is largely coming from the increase in the stronger tropical cyclones. And then looking at rainfall averaged over the country, we can see that annual rainfall again varies from year to year. The 3-year running average there in the red line shows a slightly less variation, but this overall downward trend that's given in the black line. So in summary, for the past climate, we have an observed increase in frequency and intensity of tropical cyclones. And what's not shown here is a trend towards later onset, but also this reduced annual rainfall. So what does this mean for past climate impacts and responses? So in the northern region of the country, tropical cyclones and damming practices with neighboring countries are increasing the frequency of intense flooding. And to respond to that, early action measures are in place for temporary evacuation in advance of tropical cyclone and landfall. And in the southern region of the country, this is a drought-prone region, and many livelihoods are in livestock, and less rainfall impacts food availability and quality. So responses that are in place are early action measures to support communities manage drought through microinsurance and food aid. So now looking to the future, and here we're looking at the 2050s compared to the late 2000s. Not late 2000s, late 1990s, I should say, or late 1900s. Black arrows show significant changes and grey arrows show non-significant changes. And this is the results from 5 climate model simulations showing changes in tropical cyclone frequency and intensity. And what we can see is 3 of those 5 simulations show a significant decrease in tropical cyclone frequency, and 4 of them show an increase in intensity, and 2 of those show a significant increase. The dashed lines show where there's no change. For rainfall, we have a range of values given by the projections, splitting to the north, central, and south region, where the north is wetter and the south is drier. We can see that changes in the future, for example, in the north region by the mid-century, span -20% to +25%. So these changes from decreasing to increasing are across the country, except in the south, where by the end of the century, we're expecting an overall robust message of decreasing rainfall. So in summary, the frequency of tropical cyclones is likely to remain the same or decrease. The intensity of tropical cyclones, however, will likely to remain the same or increase by the mid-21st century, but there'll continue to be high year-to-year variability. Projections of rainfall span both increases and decreases, but they agree on a robust message of decreased rainfall for the southern part of the country by the end of the 21st century. So what does this mean for responses? So investment in tropical cyclone protection measures is important, but perhaps no more pressing than in the future climate than in the present day climate. And where flood risk is an issue, it will remain and continue to be an issue. The case for drought resilience measures, especially in the south, is made stronger by the information we have when including the future climate projections. But importantly, the science can change, and as new information comes in, a new understanding, these results might change. So in terms of building on this, there's a need to work together with communities and decision makers to understand where proposed adaptation measures can address the range of future scenarios, while recognizing the need to improve climate resilience in the immediate future. And then using the people-led service approach, which Nairi may mention a little bit more, and good principles of co-production, weather and climate services can be developed to help support people make decisions to respond to these risks. So with that, I'll pass back to Nairi.
Super, thank you so much, Joe. So just a reminder to everybody, this was a scenario based on a sort of imaginary country, but actually it was also based on experiences that we've had working with different countries around the world. And it's really to give everybody an idea of, if you're managing climate variability today, which is floods and tropical cyclones, but actually what the future climate scenarios are saying, it could potentially be getting drier overall in that region or country. How can we make sure some of those actions that we're taking today are going to be also fit for the future? And this people-led service approach is something that we've developed through a lot of our development work, funded by FCDO and other agencies, with partners like World Food Programme and Red Cross. And it really just focuses on the idea of looking at those impacts first, and then working together to use the data that we respectively have available for vulnerability and exposure and hazards, to bring that information together with an understanding of community needs, to develop services that can be best communicated so people know and understand them, can take action, and then essentially to continue to review that process as the science changes, to then make sure that what we're doing in terms of early warnings and early action is still understandable, still relevant, and or needs, whether it needs improving. So with this case study in mind, I'm now going to ask some questions of our experts. And Joe, if you wouldn't mind, if you stop presenting. Yes, thank you, Joe. And I'm going to move on to Irene, and just so you know, you'll have a chance to ask Joe more questions after this initial sort of panel discussion. So Irene Amaron from the Red Cross Climate Centre, of which we have a great partnership with and have worked together to present or to complete the future of forecasts, impact-based forecasting for early action publication, and are very much working together in countries to bring together those Met services and disaster risk managers. Irene, my question to you off the back of Joe's case study is, how can forecast-based financing initiatives, and thanks for showing the slide that helps to summarize it if people on the call aren't sure of what forecast-based financing is, how can they use and benefit from future climate projections to inform early action planning now? Big question for your 3 minutes answer. Thanks, Irene.
All right, I'll try to make the best use out of that. Thank you so much, Joe, for sharing the projections that you've had. And I must say that if we are looking at early actions that we are implementing now and wondering whether in 2050 they will still be relevant, I think that is a question that we cannot answer at this point in time with a yes or a no. But there are opportunities that the climate projections bring for us. So, for example, looking at what Joe has mentioned, he said, you know, where the flood risk is an issue, it will continue to be an issue. And we're also seeing areas where we are having multiple events happening at the same time. So what does that mean for us with our FBF initiatives? One, the future climate projections help us in terms of reviewing and reflecting back on the designs of the triggers as well as the early actions, as these, of course, are developed based on the forecast, on the analysis of the forecast and an in-depth risk analysis. So definitely in 2050, by the time we get there, we want to ensure that our triggers, one, are relevant to context at that point in time, and then two, that the early actions are also relevant and able to mitigate the anticipated risk. Then also these future climate projections help us in terms of assessing how robust our impact-based forecast models are, because again, this is based on the forecast, you know. So looking ahead, definitely we'll try and see that, you know, this matches the challenge at that point in time. And then, of course, without you know, underscoring it, that our early actions need to be contextualized, you know, and this has to be based in terms of time scale. We are looking at the scale at which we are implementing these early actions, and of course, what does the climate say? But I think most important is we need to look at this, the benefits of the future climate projections beyond the FBF initiatives. What does this mean for a long-term anticipatory action? How can we adapt planning for droughts? How can we adapt planning for cyclones? How can we adapt planning for floods? With all this information that we have, and look beyond just the FBF initiatives. And how do we link that into long-term adaptation planning and eventually ensure that our programs, our activities, all that we are doing is climate smart? And then, of course, re-emphasizing what Joe said, that we cannot get the best out of these climate projections without partnerships. How can we, for example, help all people, communities, humanitarians, academias, private sector? How can we help them understand and make these climate projections usable and useful for us to ensure that we mitigate the risks that are anticipated with these hazards? Thank you so much, Nairi.
Thank you so much, Irene. And with your experience of working with national societies across, multiple countries to bring them into the forecast-based financing world and help them to understand developing those triggers, etc., I'm sure the audience will have loads of questions to ask you after this as well, so we can go into more detail with that. So over to you, Kathy, because we're moving from forecast-based financing, which is very much focused on sort of preparedness and acting before the disaster takes place so that people are well prepared. Obviously, in your work, working with governments and international organisations to support financial planning and to help build resilience to ensure that people are hopefully less vulnerable to disasters. I was just wondering if you could give us an idea of how you use or how disaster risk financing uses climate projections to inform risk and national insurance policies, so that they're fit for purpose longer term, as well as embracing the climate vulnerability across all timescales. And very welcomed, Kathy.
Sure, thanks, Nairi. So yeah, as a brief introduction, so I work in the crisis and disaster risk financing team in the World Bank, and our overall kind of mission statement and vision of the team is that financial planning to protect against climate shocks, disasters and other crises will become a core priority for all countries. So the team works globally in middle and low income countries, effectively to help governments understand the physical risks which they face, but then actually really kind of quantifying that to understand the financial risks which they face as a result of those natural hazards. And really the focus on that for the World Bank is because the economic shock from these single events can actually set back the development gains, which perhaps other areas of the World Bank and obviously the countries themselves have worked for several years to try and attain. So broadly speaking, what the team does is to provide technical assistance to the countries to help them establish their risk and then the types of financial instruments which they could put in place ex ante, so have ready in case a disaster happens, which would provide this rapid finance. So you can think of that, for example, as perhaps a contingency fund, which might be what we would have as our rainy day fund, our kind of rainy day money set aside in a bank account that we don't spend unless something kind of catastrophic, although hopefully in our own lives something quite small would happen and then we require that money. And then you can also think that we help to set up, say, sovereign catastrophe insurance policies. So this is for those lower frequency but very severe events, such as an intense tropical cyclone, as Joe mentioned earlier, or a strong earthquake, or perhaps a drought. So obviously for this work, one of the first steps we have to do is to quantify what is the risk which a country faces. So what natural disasters can it face, and what is the likelihood or probability of a certain event occurring? So actually, just to plug a quick session, another understanding risk session, the team actually has the team from the World Bank is hosting a session later today. So it's at 3 p.m. UK time, and that's on the understanding risk financing, and basically includes a few case studies that we've done. So to go back to imaginary land, if we're looking at assessing the probability of risk, so for that country, we would want to look at what is the probability of the tropical cyclone happening. And the way we do this to quantify it for, say, an insurance project is that we use a catastrophe model. So a catastrophe model simulates hundreds or thousands of synthetic but realistic events, so physically realistic events that could occur based on the climatology of the region and the peril. And the way these catastrophe models work is that they're calibrated to ensure ultimately that the output well represents history normally. So for example, the number of landfalls that you might have had, or the locations of the storms and their intensity. So a project we're working on at the moment is actually in Mozambique, where the bank is helping support a $36 million disaster fund for when these events occur. So that's their kind of rainy day fund, as well as about a $12 million to finance insurance premiums. So we look at this by saying, right, what natural disasters have occurred, what tropical cyclones, and how likely are they to occur in the future? But the catastrophe modelling methodology inherently relies upon the idea that the past is a good indication of the future. But what we need to consider now is, given Mozambique, for example, in 2019, it was the first time there were 2 major storms making landfall. We have to consider, actually, is the past a good representation of the future in the way that we build these models? Or should we start actually using these climate projections to change those rates and frequencies of storms in the past? So another area that we're looking at is stress testing, therefore, under these climate scenarios. So for example, as Joe mentioned, if there's a 10% decrease in frequency of storms, but maybe a 20% increase in the intensity, then we look to adjust these models to ensure that countries can understand the types of risks they face in the future, and therefore that this is key really to enabling that the sustainability of the financial solutions that we put in place today are actually still going to be sustainable in the future. So thanks very much.
Thank you so much, Kathy. And I think it's exactly that point of, you know, the information that a lot of planners are using at the moment is based on people's own memories and ideas of what has happened historically. And it's interesting to hear, even in the disaster risk finance world, that sometimes those catastrophe models are still using that historical information, but hopefully more and more will start to embrace the sort of future climate projection work that is out there. So it's an interesting transition now from the sort of looking at how we engage at a sort of government level to support insurance and financing schemes, but also early action protocols and early action financing, to Katusha Farah, who is the World Food Programme Senior Climate Services and Disaster Risk Reduction Advisor for different countries around the world. And she's also a specialist in climate change adaptation and disaster risk management. And I think it's a really interesting point here to also start to bring in that element of people and how we adapt and how we might need to start to look at changing our behaviours or the way we operate, the way that we manage our livelihoods, etc., to be more resilient to these this possible future. So my question to you, Katusha, is from a World Food Programme perspective, how can we use climate projections to help communities think about these longer term impacts of climate change, and also in the context of some of the risks that they're facing now, which may not obviously necessarily be the same? So over to you.
Yes, thank you. Thank you, Nairi. I think in a way it's important to think that this is about giving or providing communities with a key to interpret what is happening and the change that they are already seeing and is already affecting their livelihoods. And there are 2 points that I feel are particularly important when we look at how do we use the science, how do we use the long-term projections that we have. One is that we are now at a point where we talk about adaptation, understanding risk, understanding vulnerability. We need to look at this across time scales. We need to do this in parallel. We need to understand now what is going to happen in the next 6 months, because that's what it is really important for the farmer. We need to think what's going to happen in the next 5 years, but then also what you said, we need to think long term and what is the direction. And that will continue because of the fact that we might need to adjust. There are a lot of probabilities and lots of potential scenarios, and it will be important to continue in a way moving at the same way, trying to understand the now and the variability and the longer term and adjusting. And so, and that is key to have this information, because that will help to inform also the behavioral changes, a community at different level, and changes in practices and in in the traditional way of doing things. The second point is that when we look at how can we support communities, is that it's not just enough to have the information and have the scenario. It's about how we translate them in a way that makes sense and that is useful to people, be they decision makers at the national level who need to inform policies or investments, or community level. And so the translation is particularly important, is how we unpack and we bring knowledge that people can make sense of because it talks to them. And in a way, I want to refer to the work that we are doing together with the UK Met, when we work with the climate and food security analysis, in particular, the CLEAR methodology that we're using, because we specifically look at livelihoods. And so we work together to understand, yes, what is the impact on food security, looking at probable scenarios, but even more, how are livelihoods going to be impacted? Because that's what people understand. And that's what we bring. The second thing is that, yes, we need to start by bringing information that is relevant now. So this is what's happening for the next season. This is how the rain will behave. So a way of climate services that help to plan for the season. And then also bring in the additional information. People already know that things are changing. The traditional knowledge is not useful anymore. They see new emerging risk. They see more lightning, stronger winds, fires where there were none. And they just need to be able to make sense of that. And so by, in a way, making sure we meet the primary needs of helping them to plan for the next season, and especially with communities we work with, which are food insecure and extremely vulnerable, and at the same time bringing this context and translating this idea in the next 5 years and in the longer term, emphasizing also the potential scenarios. That's how we can work together. And I emphasized it together, and then I finish, because also in the work we do, our focus is really on having stakeholders involved in all the processes. We start with community consultation, and then policymakers when we present, when the UK Met many times has presented the outcomes, and then the discussion of based on this, based on a potential scenarios, based on what could happen, how do we adapt? Where do we invest? What information we bring down to communities? And that you can only do in a way, and you can only empower people if they're part of this decision making, if they understand the science, and if they're part of the production of this co-production process for recommendation. Thank you.
Thank you so much, Katusha. And it's so right, because even the work that we did in Mozambique with the climate analysis for food security, looking at how the climate projections are going to impact livelihoods in Mozambique, we were presenting to academia, to ministry, to users of that information, and every single time when we worked together, the way they wanted to receive that information was in a very different way. And I think at a very sort of simple level, even our forecast at the beginning of this session is even a means for us to start communicating better with our government in the UK in terms of just contextualizing and putting people into the future in that way. So thanks so much. So now it's over to the audience to have your chance to ask questions of our experts. So just a reminder to those who've perhaps joined us a bit later, we've had a imaginary land where we've had a case study where Dr. Joseph Darren, who's on the call from the Met Office, a climate scientist, presented a scenario where a country is experiencing a lot of tropical cyclones now and floods. But then when you look at the future climate projections, a lot of the indications are that generally the climate is going to get drier. And so the idea is, how can you make sure that a lot of your early action protocols, a lot of your disaster risk financing planning, and also your engagement at the community level is taking into account what will be happening in the future, and hopefully helping people to be a bit more resilient across all the timescales. So I'll probably pass over to John because he's had a clearer view on the chat as to some of the immediate questions that have come in. And obviously, please do unmute yourself or shout out if you would like to get the ball rolling with any questions. John, anything, quick question to start with the chat?
Yep. I've got a question here from my old colleague Paul. So he's asking how the uncertainties of forecasts and climate projections can be taken into account in the decision-making processes that we've been talking about here today.
Brilliant. So, Joe, do you want to maybe just quickly share some of your experiences of working with decision makers in your role as a climate scientist? And then obviously we can then hand over to Kathy or Irene or Katusha, whoever would like to take it from the decision maker processes aspect.
Yeah, happy to. Yeah, I mean, definitely, I think this is a question where everyone will have a different lens and view, and this is exactly the kind of message that we had of sort of coming together on how to tackle these kind of questions. But I mean, I think the starting point I would say is that you know, starting from the whole set of, and often overwhelming set of information that's available from climate science and future projections, it's understandable why that might seem intractable and relating it to particular decisions. But what we've done in projects in the past and are increasingly doing is trying to really understand the decision context and work with those who are making the decisions to understand what their key vulnerabilities are, what their decisions actually are, or what's in their control. An example is the work we've done with the University of Cape Town as part of the Fractal project, looking at urban climate resilience. And rather than look at the whole range of future climate projections and try and map that to decision spaces, we've taken a very limited set of plausible future scenarios and drafted what we call climate risk narratives in collaboration with those who are involved in the decision-making processes. And then through that process, you can see that actually a lot of the issues around adaptation, or a lot of the issues around interventions and actions in the short term, aren't too sensitive to the climate future that might be there. Of course, there are circumstances where it matters a lot on which climate future you take, and so that's where the discussion on the uncertainties comes in. So if there's a sensitivity to, say, a 20% decrease in rainfall, if that was happening year on year, that would really dramatically impact livelihoods. Then that's when we can sort of interrogate and look at that a bit more closely and think through what the interventions might be. But yes, I think there's a range of different approaches, but that's one example of the work that I've been involved in.
Thanks, Joe. And I think it's really important to think there are definitely some adaptation actions that could potentially be no regret in terms of supporting countries to move towards that resilient future. Kathy, do you want to maybe just give us a perspective from disaster risk finance side of, you know, given the uncertainty of these climate projections, how you can still effectively use them for planning?
Sure, I think it's a great question. I think as well, as particularly if we look at it in terms of climate shock. So very much what we look at is the big events, so the very intense tropical cyclones. I think I have to be honest that in terms of the financial planning and the way we structure them, there is such an uncertainty, as you would know, in terms of whether a storm is going to happen in general. You know, there's a lot of uncertainty around those. As we know, it's difficult to even forecast a year, or even just, you know, a day before a storm is going to make landfall. It's difficult to actually, I guess, integrate it specifically with clear outcomes into the financial planning. Because often we're looking at, well, what's the general frequency of storms, and particularly in a lot of countries that we work in who don't actually have anything set up currently, we're really looking at, you know, the current risk. So I think it is difficult to include, given that there is such an uncertainty already in somewhat the amount of storms that you expect it to, say, hit somewhere. But I think it's good to be able to have that to suggest that, you know, even if someone isn't taking, you know, isn't aware of it now, saying that there is a lot of consideration about the future. And it's certainly a question that we get asked, you know, I think now we get asked a lot when we speak with governments, you know, what about pandemics? But, you know, the key question as well has always been, what about climate change? Is this going to increase our risk in the future? And so I think it is difficult to embed, you know, perfectly quantifiably into the financial solutions at the moment in the countries that we work in, but I think it's very important for the future. One of the things, though, I do think you see it more broadly in the very developed insurance space is that you see it really being taken into consideration, for example, in the United States, where they're really beginning to look at, some of these changes around, is flood now, are tropical cyclones getting wetter? And we see that with hurricanes causing more floods, where, previously where you had that insurance policies weren't so concerned about floods from tropical cyclones, it was more the wind damage. You're beginning to see changes in the developed financial markets. And I think if I then, if we consider how things tend to flow through then to the less developed countries, I think that will start to flow through to where we work. But certainly now it's more about making sure it's in people's minds rather than as being able to actually put it into the decisions at the moment. Although, yeah, it's clearly a topic of conversation that gets brought up a lot. Thanks.
Thank you, Kathy. I'm not sure if it's happened for everyone else, but she's slightly frozen on my screen. So I think I'll take the opportunity to maybe look at one of the other questions that have come in. I think, Duncan, were you happy to ask your question up on the screen and with a voice unmuted?
Yep,
to
sure,
whoever you'd like to choose in the panel?
Oh, I don't know who to choose. I think I'll let people volunteer.
And welcome, by the way. Thank you.
Thank you very much. I think Louisa Whitlock has just asked a similar question, actually. So I suppose mine really continued on the uncertainty theme. Climate models can give us an idea.
I can't hear you, Duncan, so I'm not sure if you're muted or whether you've just, or if I've frozen maybe and everybody else is still.
Hi, Nairi, it's John. Nairi, can you hear me? It's John. So we're going to presume that Nairi can't hear us, but we'll crack on without her and I'll send a message. So Duncan, please do carry on.
Right,
and
okay.
Yeah.
Right, thank you. Climate models will give us an idea of the direct impacts of climate change, but I just wondered to what extent we can also factor in some of the indirect impacts which might affect exposure or vulnerability. So for instance, if the population of a region might dramatically increase in future because of neighbouring regions being, having very extreme impacts and people wanting to migrate. And I suspect the answer is it's very difficult to do that because if we think modelling the climate is uncertain, then modelling human behaviour is probably even more uncertain. But I just wondered if there were any ideas about that.
Thanks, Duncan. Maybe I'll come in if anyone else wants to contribute as well. So I think it's a really important question, and also, yeah, it reflects a similar question to what Louise was asking. I think to be clear, the climate projections that I was talking about, they don't include sort of local level and even national level changes in things like changes in urbanization. There are impact studies that do that, and use of climate models to drive impacts models that do that kind of work. But yeah, they are the kind of, as you described, the direct effect of climate change, and therefore the sort of more complex responses and connecting that in models is a key challenge. I think there's two ways to approach it, and one is the kind of through the modeling approach, and there are some quite sophisticated models there of actually trying to model some of these behaviors and potential futures in different responses. And then the other approach is a kind of more qualitative, consultative approach with those who are responding or being impacted by the information. And I think you need a mix of approaches depending on the kind of decisions they're informing. But it's definitely a complicated area, and I think it's actually an area that we are increasingly trying to explore new methods and new ways of addressing this, because people don't feel the direct impacts of climate change at a sort of continental scale. They very much feel the impacts which are manifested through other changes in the environment and indeed in socioeconomic systems, and that's how people experience the sort of the climate change impacts more broadly. So I know that doesn't completely answer the question, but I think it's an agreement that it's a difficult area, but it's something that I think is really important. And certainly, just to add one more thing, I think we're learning from what's being done in the impact-based forecasting and on the nearer timescale responses as well, for how we both communicate and understand long-term decision making. So I think bringing these timescales together is really important to help do this.
Thanks so much, Joe. Katyusha, were you going to have a word?
Yeah,
super. We've got a few more questions. So just generally to our wonderful panelists, as lovely and short and sweet as possible, please. Thank you.
Will. Just to say that with the CLEAR, we are trying to attempt to do that. So we're looking at impacts on livelihoods and trying to understand also coping strategies of people and type of decisions to take. And right now we are introducing a lens on nutrition. And in the Philippines, we're trying to work with IOM to bring in data on migration. And so it is tricky because it is a complex analysis and you can do the analysis based on the data that you have. But that's why, as I believe Irene said before, partnerships are key. We are very keen to add different layers to the work we're doing and work with other agencies that might have the data that we don't have.
Exactly. I think that's really key in terms of, part of the fantastic opportunities and partnerships is that everybody has different focuses on data that's important for their world. And when you bring all of that information together, it's a fantastic opportunity to then develop a climate service that makes sense. Louisa, we've got one from you on the chat box. Would you like to ask it direct, or would you like me to just read it out? Unmute yourself and go for it if you're happy with the direct. I've come off camera, by the way, everybody, because I keep freezing.
Hi, actually, I think my question has pretty much been answered in the response to a previous question, but thanks very much anyway.
No problem, Louisa. Thanks for jumping in. And Evie, yes, the UK forecasts, the future ones, are publicly available. We've only got 2 at the moment, but they're very much aligned with UK climate projections, UK CP18 climate projection modelling. Obviously, Joe can probably answer a bit more information on that one for you. I think there was a slightly more technical question as well about the climate, where are we, about the extent to how the regional and national level projections are used. Was that the same one that Louisa just cleared off? Any further questions that I haven't covered that need to go out to everybody? John? Sorry, I missed a big chunk there.
So I think Louisa said that she felt that her question was answered. Evie was asking about the Met Office forecast. It might be interesting to get a little bit of clarification from Evie about what she means by forecast. Is she talking about climate projections or the video that we showed earlier or something like that? And then she asked a really actually interesting question about the representative concentration pathways and so on. So it might be, Evie, do you want to step in and give a bit more context to your question?
So I think this is Kathy, and I actually work in the same team as Evie, and I believe Evie's actually just had to drop off for another meeting. But she did leave. She did mention to me the question she was going to ask. So I think one of the things, yes, was about the availability of the forecast, and I think the other was because she actually messaged me about it, and I said, oh, please do ask, was around the uncertainty between so you mentioned that you use different models, say with one RCP scenario, and you have significant or insignificant changes. And then obviously you presumably use those same models for another RCP pathway. And it was whether that you see there is greater uncertainty between say the GCMs that you use within each RCP than you do between the RCPs. So really, I guess, yeah, where is the uncertainty coming from, I guess, in your analysis? That's to paraphrase what I believe Evie was going to ask, and I can pass the message back to her in the answer.
That's
perfect.
A great question.
Thanks,
Joe.
Yeah, over to Joe. That's all right,
yeah,
Joe.
I think it's actually reasonably straightforward to answer. So there's, for the last 10 years or so, following a method developed by Ed Hawkins and Rowan Sutton, there's you can apportion the uncertainty to sort of the 3 main drivers, which are the sort of emission scenario or the concentration pathways, the models, and also natural variability in the system. And a very short lead time, so over sort of the near decades, it's the model uncertainty and the internal variability which dominates. It's only when you get into the sort of the sort of second half of the century that the scenario uncertainty starts to dominate the spread. And there's a really sort of neat tools and information there where you can see it depending the scale of information as well. The smaller scale you look, the more it's dominated by internal sort of natural variability as well. But yeah, towards the end of the century is where the pathways have a big effect. So whether, you know, basically society's choices impact how much temperatures are likely to rise by the latter part of the century.
Excellent. Thanks, Joe. And I had just taken off my video, everybody, just because I think I kept freezing. So apologies that you thankfully others have stepped in and answered questions, so it's all good. Now that's quite a technical question. Does anybody have any further questions for use of future climate projections in any other forms of planning, or where you might have had some experience that you'd like to share yourselves? Doesn't necessarily have to be a question, but maybe some experience that you've had of trying to incorporate this future information in your work? Maxine, I might pick on you to share a bit of information around. Oh, Kathy, go for it.
So I was going to say that I think, was it Duncan earlier who asked a question about how it could be used for financial planning, and I know that my internet dropped off at that point. And actually there's a lot of work going on with central banks as well, really looking at how climate projections can help them understand the transition pathways and the potential kind of economic impacts. And it's very interesting. It's just an area that I'm beginning to understand more about, but looking at, you know, whether it's labor productivity. So if it gets hotter, the fact that people in different areas won't be able to work at certain times of the day, how does that impact it? And what are the long-term changes of that? Or even, for example, if you consider that it may be that mortgages start to default, because actually if your home is now in an area that's going to flood much more likely, your property in the end becomes worth nothing because no one wants to buy that property off you because it's going to flood all the time. And so a lot of this is really very interesting areas. I mean, relatively interesting areas about how, you know, economies are really thinking about the longer term impacts of this. And really considering, is the bits of their kind of economy that they're going to have to write off. And it's very interesting when you look at, you know, the larger economies and those who are dependent on external outdoor labour forces versus indoor labour forces, about how it works. And just to highlight other things, then, you know, there's, well, to keep labour productivity up so people could install more air conditioning, but then does that in the end kind of exacerbate the very problem that you're trying to solve? So there are a lot of, I think there's not many solutions necessarily, but there's some really interesting kind of work that's being done on how all these climate projections will lead to big differences in, you know, financial solutions, whether it's at the broader kind of central bank level, individual households, firms, or everything. So it's just a quick aside from me on an area that I've only really just started to learn a lot more about, but it is it's very interesting to see the highest kind of echelons of our governments, as it were, really starting to pay attention to this as soon as you say that it might impact their central banks rather than just their, you know, day-to-day lives.
Absolutely. I think it's really well said, Kathy, as well, because I think obviously given what we're all experiencing at the moment and people needing to work more and more from home, what's possible in terms of doing that. And then, as you say, potentially some of the impacts of heat on people's health, but also their productivity. I think it's definitely going to be something in future, well, hopefully, which will encourage decision makers now to really start embracing the science a little bit more, and hopefully reaching out to make it clear what kind of language they want to receive that information as well, which makes it useful for them. So so we're just about to probably be cut off, actually, because we're getting to the end of the session. So I wanted to take the opportunity to thank everybody so much for attending the session, first off, Thank you so much, Understanding Risk Community, and I hope you enjoy the rest of the conference. I'm sure you will. There's loads of fascinating sessions ahead. And thank you again to our experts, to Joe and Kathy and Katusha and Irene, all of which we could ask you so many more questions, but thank you for your really valuable input. And also finally to John for helping with all the technology, and to Steve as well from the World Bank Group for helping and for managing all the questions. And yeah, have a fantastic rest of the conference, everybody. All the best.
Thank you, Nairi.
Thank you, Nairi.
Bye-bye.
Thanks, Nairi. Bye-bye.
Thanks, Nairi. Thanks all.
Hi, Nairi.